Well, hello again. It is time to go to work on this 1935 Crosley chassis. Really nothing to it. It's pretty minor. You know, we've worked on stuff that's 5 times bigger than this. You know, in the Hallicrafters and the Hammerlands, and I can't remember what else. Anyway, this is going to be a piece of cake. I went ahead and tested all the coils earlier. I told you that in a previous video. And I went through and tested various resistors, everything. The resistors look to be in really, even though they're dog bones, they really look to be in really nice condition. But that doesn't mean anything. You know, I tested them all out. They seem to be okay. I'll test them again just to make sure. The electrolytic capacitors have been changed in this radio. There was a large, tall metal can back here in that thing right there, and that, get this out of the way, and that right there, but it's long gone. What they did was they removed it. I might have something out in the garage or out in a shop rather that I can stick in there, you know, just for aesthetic purposes. But they replaced it with these 3 capacitors here, here, and here. Now some of you are going to say, wait a minute, John, that's not an electrolytic capacitor. These 2 do not look like electrolytic capacitors. And John's going to say, wrong, 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 you are wrong. Look, this is a 1935 radio. 90 years, you know, ago, almost. Things are going to be different back in 1935 than they are, you know, in 1940 or even 1936. These look like regular standard wax capacitors. But this one, now this one, you know, you would say, yeah, that's probably an electrolytic. But these 2, no. Yes, they are. This line on here indicate positive ends, okay? The positive end. My dog must, I don't, there must have been a bird at the window. My dog's going bananas. And then again, what do we have right here? You remember what we did a while back? And I showed you a double capacitor with a center ground. Okay, there it is again. It popped up right here. You have a capacitor on this end, a capacitor on that end. This is where the ground is. The 2 wires from the other side of the capacitors come out and connect to here, and this, of course, connects to ground over here. Alright, it'll go down there and hook somewhere to the ground anyway. But anyway, I think, you know, I think after we do one thing, we might be able to actually fire this radio up, bring it up slowly on the variac. We may get lots of hum. I don't know how good these electrolytics are. And, you know, maybe we'll get some sound out of it. I don't know. But first we have to do one thing. But before we do that, we're going to go over this schematic here a little bit with some things some of you might like to know. Let's take a look at this booger. You'll notice that on this schematic, nowhere does it have a ground symbol, you know, this sort of thing, you know. There are no ground symbols anywhere on this schematic. Let me zero in on here, I'll show you. No ground symbols. Now, of course, the first question a newbie would ask was, well, how am I supposed to know what's grounded and what's not? You know, I would ask that if I was just starting out. Wait a minute, what happened to all the grounds, you know? Well, what they did in this radio was they put this dark line in across the schematic. All the way across. Everything's hooked to it, and this thing is hooked to ground. If you come down here, follow it down, it comes to a black wire. That black wire is a ground to the chassis. Just remember, that's the way it was in the old days, okay, back in the 30s. Anyway, over here we have another capacitor. I'm not sure what that one is. I'm going to see this is your classic example I keep harping on all the time. When you put these capacitors in there, put them so people can read the values. They do have a nice pictorial of the chassis. Let's see if we can figure out what that is together, okay? Lucky us. Okay, there it is right there. That is the large capacitor. Right there. It's right there. Just kind of neat. Let me see if it's got a number on it. It does. Let's see what it is. 21. Alright, now let's go to the parts list. See what 21 is. Okay, 21 is a 1 microfarad. It's just a standard 1 microfarad. Where's my pencil? 1 microfarad, 100 and let's see, 21, 1 microfarad, 160 volts. Okay, so now we know what that is. Now all of you who have been watching these various vintage radio repair videos, mine and others as well, you've seen the Can-ohm resistor. There's a flat piece of material inside here. This thing is riveted to the chassis. There's a flat piece of insulating material that runs the entire length, and wrapped around it is wire. It's a wire round resistor, and then they tapped off it in various places wherever it was needed. In this place, or in this case, they tapped it off here, here, and here. So that automatically told me that there's a resistor between these two, and then there's a resistor between these two. But when I tested them, they're wide open all the way. Can-ohm resistor, can-ohm, it's a resistor in a can. They come up with the term can-ohm. Kind of a nice play on words, actually, I've always thought. But Can-ohm is a trade name, an actual name that the company had, okay, that made them. So I'm going to hook these up and I'm going to show you what we got. How do you test a Can-ohm resistor? Now normally a repair tech, he would just take his probes, his 2 multimeter probes. He would just stick one there and then take a reading, and then stick one there and take a reading. That's the way I did it. But for our purposes here, and for those who have never done it before, we're going to do it this way. I took a couple of gator wires and hooked them on, one on each of the first two connectors that come off that Can-ohm, and then I just clipped them onto the multimeter probes over here. Kept them away from one another so you don't make contact. Okay, now let's go down through the scales and see if we get a reading. A little bit too far. There we go. I better use my right hand. Okay, we're up to 200K, 2 meg, 20 meg, 2K, 200 ohms, nothing. Dead as a doornail. Okay, let's take the, we'll leave this one here in the center, and now we'll take this other one off. We'll stick it way over here on this end. See what we get there. So now we've got one here, and in the center. We've already tested this other one, so it's not going to work. So let's go through that one. Two meg, 20 meg, dead as a doornail. Now let's go, just for the heck of it, let's just go end to end. Do it end to end, you know what we're going to get. It's moving on down to 0, okay? Okay, it's wide open. It's got to come out of there. Now let's go to the schematic and find out what values we need for those 2 resistors. One between here and here, and one between here and here. Well, I just took a look at this, and you just cannot get any easier. You'll notice that these are your 3 electrolytic capacitors that I pointed out. The 2 that look like wax, and then the blue one, And I labeled them, I've got it written on there what they are. And you'll notice that one end of this Can-ohm resistor comes off the connector and it goes to ground. This is a really bad solder job here. But anyway, it comes off and it goes to ground, which means the Can-ohm resistor goes. Now here's 2 resistors right here. I wonder if they could be them. One end does go to ground. Imagine this being your Can-ohm here. There you go. There's your Can-ohm, okay? One does go to ground. Now the center between the resistors is a positive of electrolytic of 10x. Let's see now. This is the 10x. I had previously labeled it. And let's see if the positive end goes to the center. Well, there's the positive end right there. Come on, clear up now, clear up. There we go. There's the positive end right there. It does go to the center. There's the one on this end, there's the one in the center, and there's the wire coming out of that big blue one. Well, I think we figured out what's what here now. So now we'll just do one more if you want. The two positives from these two electrolytics go to the opposite end of the ground, all the way down to the other end. Let's see if that's right. That would be this connector right here. Let me see, a positive end. Well, there's the positive end coming out of that electrolytic, and it's connected to that blue wire that goes down there. Yep, that goes there. Now here's the positive end out of the other electrolytic. And where does it go? Oh, it goes over the same place. Yeah, so that's it. We now know that the two resistors inside this Can-ohm are these two resistors here. Well, how about that? So that's 41Y and 41Z. Let's see what the parts list has to say about that. Well, once again, it's pretty easy. Look at here, we've got 41Y and 41Z with the, I don't know what that sign is pointing over here. It says one of those is 8,500 and the other one is 25,000. So 25K, where'd my pencil go? It is 25K and 8.5K. There it is right there. I want to make sure. Okay, there you go. You get a good picture of it now, I think. Yeah, there we go. Boy, this camera with white. Anything is white, forget it. Anyway, so that means that on the short end of the Can-ohm resistor would be the 8,500. On the long end would be 25K. So let's go back here and we say, well, this is the 8,500. This is the short between these two, and then the long one from here all the way to the other, that'd be 25K. But what about wattage? What about, this? They put this thing against that chassis and riveted it in for a reason, because there's a lot of heat generated from this. That's why these things wiped out so much. So, my mentor Brendan and I figured, of course, I had figured it out just by hook and crook. Quite a while ago, I was replacing these things with 10-watt resistors. I mean, that was overkill, okay, because I didn't really know what the wattage would be. But he sat down, he figured it out, all this crap. He said, John, you can get by with 5-watters. Okay, so I'm going to put a 5-watt 25K resistor between here and here, and an 8,500. Actually, I'm going to use a 10K. I'm going to put a 10K in there between here and here, 5-watt. Now, how am I going to do that? How do I do that? Well, first of all, this thing has to come out of here. I'm going to drill out these two rivets. One right there, you can see. There it is. One right there comes out. I'll have to drill it from the outside. And the other one's down here. I'll have to drill it from the outside of the chassis. And then I'll have to cut these things off here and here and just let them dangle, because I'm going to solder them onto the new terminal strips I'll be putting in. If I'm lucky, all I got to do is solder the tab up instead of disconnecting the wires and do all that stuff. We'll see. If I have to disconnect the wires, I will. It's not that big a deal. It doesn't bother me any. And as soon as we do that, we'll go ahead and we'll tear this baby open and let you see what it looks like inside. If you've never seen inside a Can-ohm, get ready. It'll be coming. Well, drilling's not going to work on these rivets. They're rounded on the outside. Bummer. So I'm going to have to take my little rotary tool here and just this little grinder and just kind of grind them down slow and easy, both of them, until I can punch them through from this side. Everything is already loose from the Can-ohm on the inside. I clipped each of those tabs off. It went very smooth, and then of course when I come out here, it's a problem child. Well, let's get started. By the way, when you do this, you go very slowly. You don't need grind marks all over the chassis on the outside. You got to use your head on this stuff. That's what I'm talking about right there. Just got to take your time, grinding slow but easy. Slow but easy, back and forth. Eventually you'll get there. Just don't get in any big hurry. It's a two-handed deal. You got to have one hand holding the other as you gently go back and forth, back and forth. Well, there she be. Did pretty good. Let's see how well I did on chassis. I hope I didn't scratch it too much. I got a few scratches, just barely noticeable scratches. Where's the other one at? Oh, over here. Again, barely noticeable. You're going to have a couple of those types of things, but once I'll sand it down just a little bit with some very fine paper, and when we paint it, you won't even see it. Alright, now, what do we do next? Well, we're going to go ahead and open this puppy up. I'm just going to split it apart. You can see where I whacked off the 3 tabs. 1, 2 down there, and 1 up there. Let me zoom in here a little bit. Okay, let's go ahead and split this baby apart. Well, there it is. You know, I remember when the first one I opened up, they were a bear to get them open, and they're still a bear. That's some thick metal. Anyway, here's the resistor, flat thing I told you about, and very, very thin wire. I don't know how they did that back in 1935. I mean, this is like hair-thin wire, maybe even thinner. And they did that without breaking it. I don't know how. Anyway, the taps. This is what the tap looks like inside. That that the wires were soldered to that I clipped off. And that's all there is to it. But this metal, and of course, this thing here is insulated from the can with this. It looks like shellac impregnated paper of some kind. It's not just wax. It's a little heavier than that. I think they use shellac or something like that on it. Can-ohm resistor. It worked. They got pretty hot though. Now we're going to be replacing that with these 3 terminal strips. We're going to put these resistors, the 10K and the 25K, between them. After I'm going to be gluing these to the chassis. And we'll soon have a brand new Can-ohm resistor, compliments of 2024. One more thing I noticed, well, I didn't notice after I did all my testing on the chassis on this thing. I tested the tubes, of course. And the rectifier is completely blown out. I mean, it was shot. Didn't even light up, nothing, dead. So, and the output tube was very, very weak. So I went ahead and ordered those from our good friend Bob Dobush at Find the Tube. So they're inside this box. And that's going to end this video right here. And hopefully you learned something. If not, well, so a lot of the stuff was for the new guys. The old guys knew all this crap, just boring stuff. But if you want a little refresher, hopefully it worked. But all the rest of the tubes are okay, coils are okay, resistors are okay, except for this mess. And I think maybe we might be able to just bring it up very slowly on the Variac next time, because those electrolytics do not look in bad shape. They're just not in that bad a shape. There's nothing leaking out of the ends or anything. Pretty good, I'd say. Now, of course, we will replace them, but it'd be kind of neat to see if the radio will give us a little noise. So until next time, this is John.